Before we go any further, we're just going to have a quick look at the formula sheet. So this is the new formula sheet. Here we've got our log and exponential function rules. Remember, we looked at these in prelim. Log to the base a of a to the power of x is just x, because you've got to look at the log to the base a of a. That just cancels and you're left with x. Because you can bring that x to the front. That's x times log to the base a of a, and we know that log to the base a of a is 1. All right, so that equals x. This a to the power of log to the base a, that cancels out as well, and that equals x as well. So you do have those rules on your formula sheet. Yeah, this one here is your change of base that we looked at in prelim as well. So log to the base a of x. Because, for example, you couldn't work out, say, log to the base 2 of 7 on your calculator. You've got to take both those to either base 10 or to base e to be able to calculate them on your calculator. So that's log to the base b of x over log to the base b of a. You would use this by making that b either an e or a 10. That's to help you enter something on your calculator. We looked at that in prelim. And here is another rule. A to the power of x. So you would only use this rule if you needed to, is e to the power of x ln a, all right? Now let's look at our derivatives. So this is differential calculus. Function of x to the power of n, we know all about that. You bring the n to the front, you write out your function, you drop the power by 1, and you times by the derivative. I know it looks weird, but see, the n is brought down to the front, you write your function, drop the power by 1. They're always putting times the derivative at the beginning. Times the derivative. That is your product rule. This is your function of a function rule, or chain rule, sorry, okay, which we don't use, all right? Well, we don't use it in that format. We just use this instead, okay? You've got your quotient rule. There's your derivative for your trig functions, okay? Now, also here, we've got the derivative of e to the function of x is e to the function of x times the derivative. They put the derivative at the front, which is fine. Yes, they're all on here. Right, the derivative of the log of the function of x is, we were doing that yesterday, it's 1 over the function of x times the derivative. So they've got the derivative over the function. Now, this is what we're doing today, these two. Okay, so let's look at this y equals a to the function of x and compare it to the e to the function of x. So when you do e to the function of x, the derivative is e to the function of x times the derivative, right? Let's look at a to the function of x. It seems like I'm over here that it is a to the function of x times the derivative. Can we see it? What's the difference? Times ln a. So it's almost the same rule, except you're multiplying by ln a. Can you see it? So it is like e to the function of x, but it's a to the function of x times the derivative. The only difference is multiplying it by ln a. Got it? Now, you might say, but why is that rule different? This actually, the a to the function of x is the same as this, because if a was e, what's ln e? Ln e is 1. ln e is 1. So a to the function of x and the e to the function of x are actually the same rule. It's just that e is a specific value of a. Because if I applied this rule here that I'm circling for e to the function of x, I get ln e. And ln e is log to the base e of e is 1. So they are actually the same rule. To the base e of function of x, which is ln function of x, and log to the base a of function of x, again, really the same rule. Look, you've got f dashed x on fx. Look down here, f dashed x on fx, except there's an ln a here on the denominator. So really, for this ln function of x, there's an ln e on the denominator as the general rule, but ln e is 1. So it's not put in there. So they are actually, if you look at the similarities between them, they're very similar. The only difference is an ln a. So the only difference with e to the function of x and a to the function of x is the ln a here. And the only difference between ln function of x, or log to the base e of function of x, and log to the base a of function of x is an ln a as well, but it's on the denominator this time. Otherwise, they're identical. derivative of the logarithmic function. We know that if these were the rules that we knew already, y equals ln function of x, then dy dx, we do it like this, 1 over function of x times the derivative. But the new rule is log to the base a of function of x. Again, you've got f dashed x on fx, but ln a on the denominator. Okay? Remember, you do have your formula sheet previously. We looked at e to the function of x, which we know is e to the derivative is e to the function of x times the derivative. But if we're looking at y equals a to the function of x, again, same rule, a to the function of x times the derivative, but then multiply by ln a. So just looking at the link, the similarities, okay? And we'll do a few more as well. So dy dx is, isn't it, come on, that, or you can just look at the rule there. It's going to be ln, you can just go straight to the formula sheet. ln 3, what else? Times 1, which is f dashed x, times 3 to the x. Okay? So just using the formula we've got. So it's of this format, it's ln a, which is ln 3, times the derivative of the function is 1, times 3, times your original thing, which is 3 to the power of x. I'm just substituting the a for a 3. No? Again, we've got y equals 3 to the power of x. If you want to write it as in this format, y equals a to the power of function of x, that's what's on your formula sheet. Your function of x is x. What's your f dashed x? So this is what's on your formula sheet, y equals a to the function of x. So your function of x in this case is an x, got it? Your f dashed x is 1, if you differentiate that, and your a is a 3. Okay, so then you can substitute it in. Look, you know what you might want to do? It's very similar to e to the x. So there's your a to the x times, you know how when you differentiate e to the x, you get e to the x? So you're basically getting 3 to the x here, but then we're doing the ln of 3 there. See, it's because this x, when you differentiate it, you get a 1. If you want to differentiate y equals 5 to the power of x, it's like e to the power of x, right? Which is just the derivative will just be that times ln 5. So for example, when you're doing y equals e to the x, the derivative is also e to the x. But it's really e to the x times ln e, which is e to the x times 1. That's really what it is. But you just know it as if y equals e to the x, then the derivative is e to the x. You know why it's just looking the same? Because your function, when you differentiate this function, you're getting 1. No? Yep. All right, I'm going to do some more. Your formula there. We'll write down here exactly what we've got. What's a? Compare it to that. What's a? 2. What's your function of x? 3x plus 5. What's your f dashed x? 3. Now you can just substitute into the formula. Does that make more sense for you? Because you've got the formula there. So if y equals a to the function of x, then dy dx is ln a, the derivative of the function, and then just write out what you started with. Okay, that's how you look at it as. So therefore, dy dx is, what do we do? ln a, which is ln 2, the derivative of the function, which is 3, times the original thing, 2 to the power of 3x plus 5. So how would you write that nicely? How would you write that nicely? What would you put in front of what? Go out. It's not times 6. That is 2 to the power of that. That is just a 3 on its own. So where would that 3 go? Out the front. I would put that 3 out the front. 3 ln 2. Yeah? You can't do 3 times 2 is 6 because this is 2 to the power of something. It's not just an ordinary 2 just sitting there. So the 3 would go to the front. So we've got 3 ln 2 times 2 to the power of 3x plus 5. Or you could see that written with a bracket. So it would be 3 ln 2 bracket 2, 3x plus 5. For this first one, I would just write ln 3 times 3 to the power of x. Or even just put a times symbol in, it's fine. Or 3 to the power of x, ln 3, either. It doesn't matter. Just put a times. Just put a times. You just got to be careful. You don't want them to think that it's, for example, ln of 3 times 3x. You could even put that 3 to the power of x at the front times ln 3. There's definitely no confusion there. Do you know what I mean? You could even put that at the front, 2 to the power of 3x plus 5 times 3 ln 2, but it's fine like that. But just make sure that this 2 to the power of is not part of the log, because it's not. All right? 5 to the power of x over x squared. So what are you going to do first? What's u? U is 5 to the power of x. U dash is. Remember, 5 to the power of x is very similar to e to the power of x. What's it going to be? 5 to the power of x times ln 5. Yeah, it's going to be ln 5 times 5 to the power of x times 1. So if you think of 5 to the power of x as being similar to e to the power of x, you'll get that 5 to the power of x. You're supposed to differentiate that, but you don't see it when you differentiate e to the x because it's 1 times ln 5. So we've got ln 5 times 5 to the power of x. What's v? Anyone? X squared, and v dash is 2x. So your derivative will be vu dash minus u v dash over v squared, and we have to substitute. Look, you have the formula sheet, so use it, all right? Got x squared times ln 5 times 5 to the power of x minus u times v dash will be 5 to the power of x times 2x over v squared is going to be x squared squared. Now, I should be able to factorize out. What can I factorize out on the numerator? Look at the x's and the 5 to the power of x's. What can I take out as a common factor? I've got two terms on the numerator. 5 to the power of x is a common factor. What else? And x is a common factor. So I've got x times 5 to the power of x as my common factors. What am I left with? X ln 5 minus 2 over x to the power of x squared. Squared is x to the power of 4. What could I cancel out? Anything cancel between the numerator and the denominator? 1x. So that x will go and I'll end up with x cubed. So I've got 5 to the power of x, x ln 5 minus 2 over x cubed. Which rule? The rule? Product. So what's u? U dash 3x squared. V is 2 to the power of 3x. Now, you've got your formula. The formula is the following. If y equals a to the function of x, then y dash or dy dx will be ln a, won't it be a to the function of x, you write out times f dash x. Okay, so v dash is going to be what? ln what? ln 2. You write out your function, a to the function of x times the derivative of 3x, which is 3. So I'd be putting the 3 out the front. 3 ln 2 times 2 to the power of 3x. All good? All right, so let's keep going. So the derivative, dy dx is, we can do, I'll do u v dash plus vu dash. So u times v dash will be x cubed times 3 ln 2 times 2 to the power of 3x plus v times u dash is 2 to the power of 3x times 3x squared. You should be able to pull out a common factor. A few of them actually. So you want to be looking at your 2 to the power of 3x's separately, your x squareds and numbers. 3 separate categories. Look at whole numbers. Can you see anything? So this plus, that's one term. This is the other. What is in common between them? Go for numbers first. The number 3 is in common. What else is in common? No, not just 2, but 2 to the 3x is in common. And so is, how many? X squared. So basically the whole of the last term is in common. So we've got 3 is in common. X squared times 2 to the power of 3x. It's all in common. And then what's left over in the first term? What am I missing? The 3 is in. An x and an ln2. I've got the rest. Plus. Now, if that is identical to this, what do I put here? Plus 1. I know that looks horrible. These log functions differentiate the following. We've got y equals 2, no, not that one. Y equals 2x plus log to the base 4 of x. All right, what's our rule? If y equals log to the base a of the function of x, then, remember, what's the normal one? Isn't it 1 on the function of x times the derivative? So it'll be f dashed x on the function of x. Where does the ln a for this one go? On the denominator. Times ln a on the denominator. Okay? So it's the same. Like if I cover the ln a, that's the result we get for log to the base e of function of x. It's f dashed x on fx. What's the only difference? ln a. Why isn't it in the other one? Because ln e is 1. That's why it doesn't appear in the other one. So let's go. So what have we got when you differentiate 2x? You just get 2 plus, we get f dashed x. I'm going to write it here. F dashed x on fx ln a. And then I'll do it. 2 plus. All right, what's the derivative? What is your function? Your function is x. So what's the derivative? 1 over your function of x is? What's your function? It's x times ln 4. If I asked you, now when you look at that, if I ask you to differentiate if y equals log to the base e of x or ln x, what's the derivative? What's the derivative of ln x? We did it yesterday. 1 on x. Okay, so can you see you've got log to the base 4 of x. The derivative is 1 on x times ln 4 because I don't have e. It's very similar to what you were doing yesterday. So this is what you were doing yesterday, differentiating ln x, and you were getting 1 on x. All right, this is, yes? Let's differentiate log to the base 3 of x squared plus 3x. All right, there's your rule up here. Okay, you can write it out. Then the derivative will be f dashed x on ln a function of x. Might help you to write the rule. So, and you can do some setting out on the side. What's your function? I don't mind. You can do some setting out on the side. What's your function in x? X squared plus 3x. What's your derivative? 2x plus 3. And then just substitute them all in. And what is your a in this case? 3. So what I've done is I've written out the rule here in my working out. And on my little side, I've written what the function is, what its derivative, what a is, and now just substitute it in. That might be better. That's what I would probably do if I were you. I would write out the rule. I would write on the side what function of x, f dashed x, and a is, and then substitute. All right? So f dashed x is 2x plus 3 over ln 3 times, no, I've done it, oh no, times x squared plus 3x. I don't think you can simplify that. Okay? Just leave it. You can't. No. You could pull out an x as a common factor. So I could go 2x plus 3 over, can you see how I've got x squared plus 3x and x is a common factor? I could pull that out to the front. X ln 3, what else would I write now? If I pull out x as a common factor, x plus 3, if you wanted. All right, now we're revisiting the log laws. So differentiating logs using the log laws. Actually, what am I